Hi guys, welcome back to my channel Mr. Electron, and in this video I'm going to teach you how to generate electricity from this type of car alternator. Now I got this from a scrap market and it was in a pretty good condition. As you can see, it's black in color and it is running really smooth. And guys, it's running so smooth that I even thought that the brushes might have been worn off. It's like that there is no friction between the slip rings and the brushes at all. You can see how smooth the movement of the shaft is with one finger, little friction and it is running. So guys, this is the back view of the alternator. These two are the brush terminals as always, and this is the place where the slip rings are, and it is covered in the case. This is the socket for ignition, and this is the main positive terminal of this alternator, where the output positive appears on this and the output negative is the entire body of the alternator, as I told you in many of my previous videos. Now this alternator is from Ascent Car. Someone who owned the car, this alternator, wrote it on this alternator. As you can see, the brand name Valeo, VALEO. So yeah, that's it about the back view. This is the rectifier, the voltage regulator and all. Now comes the winding and the label of this alternator that defines how much the voltage, output voltage, and how much the current is. So guys, you can see that the copper wires are really nice and thick, of course. And that's the close-up for the two brush terminals, this upper one and this lower one. One more interesting thing guys, here you can see that double cables have been used as one for more current, two from here and two from the other side, making it as one and in a much proper way. And same for all the three wires coming from the armature in the form of three-phase star connection. So guys, this is the cover for the back of the alternator that I got with it. Although I opened this up yesterday when I was working on this alternator to see how much current or voltage it was generating, I would like to show you the label printed on it. You see, 13.5 volts, 90 amperes. Yeah, it can easily charge any available car battery or even a truck battery. 90 amperes is too much. Now guys, I'm going to tell you how to convert it into a working generator and charge your car batteries with it from the start. So the first process is to take the back cover off. So initially the back cover was held with these nuts. So now I'm not going to place the nuts back. You get it right, the nuts are here, you have to open it and then remove the back cover, and it's like this. Okay, after that there are two parts, armature winding and the rotor winding, rotor or field winding, you can also say field winding. Now guys, as I have already told you that these two are the brush terminals. Now the upper terminal is in direct connection with the negative body of the alternator, like this bolt, this bolt, these all are negative, even this body. This is in short circuit connection with the upper bolt. So no tapping needs to be given to the upper terminal of the brush. All you need to do is solder a wire to the lower terminal, and to activate the rotor, the second terminal is going to be the body of the alternator, which will activate this terminal. It is connected internally, the body of the alternator, to the upper terminal. Okay, so guys, now I'm going to give this green wire tapping on the lower brush terminal. Yeah, you can see that it is stuck pretty good. And no connection needs to be given on the upper terminal of the brush because it is in direct short circuit connection with the body of the alternator. Okay, so guys, this alternator is almost ready to be used as a generator. So let's place everything like this, placing the back cover. Okay, so guys, now I'm going to test this alternator by running this car headlamp bulb, 65 watts. Okay, so guys, now comes the connection of the load to the alternator. So the first part is take any of the load terminal, if positive and negative does not matters for that load, and go for B positive. This is the positive main output terminal, and keep it held with a clip. With that being done, take the other clip and the other terminal and connect it either to the body of the alternator or one of the terminals other than the positive one. Like I can connect it here or I can connect it here. Let's connect it here. So this is connected. Now the output has been connected. Now comes the part where I will have to excite the rotor winding, for which I soldered this wire. For exciting the rotor winding of this alternator, I'm going to use this lithium ion battery pack. Now the output from this battery pack is only 3.7 volts, which can glow this bulb but not to its full illuminance, because the voltage is not much even though the current is high. So keeping it like this. Now guys, we already know that the body of the alternator is negative, and this open terminal from the battery is also negative. So negative will be connected to the body of the alternator being negative. Now let's connect it like this. And the positive wire, which is this green for the brush, will be connected to the positive terminal of the battery. Yeah, you see the spark? This means the connection has been established. So guys, now that everything is in place, it's time to do some rope rotation. So let's place the alternator a little backwards, wound the thread. So guys, the thread has been wound. Now it's time to connect the rotor winding. Now when I will pull the thread, you should see this 60 watts bulb glow. Okay, keep watching the screen. Wow. Now let's turn off the light and do this test again. So guys, all the lights have been turned off except for the minor LED light that I use for these kinds of tests. So now you should see the proper illuminance. Okay. Wow, you saw that it grew to its full illuminance. Now guys, although you saw it run at a pretty good potential output, but there was one issue, that a rotor is actually being excited right now also with this 3.7 volts pack, which results in more RPM to attain 12 volts with an input of just 3 volts. So to get higher output voltage at lower RPM, there is another scenario. Okay, so guys, I've removed the bulb and I've connected this multimeter to measure the generated voltage and generated current by this alternator. Okay, pointing it towards 20 volts DC mode. Okay, the rotor winding has already been excited with the same 3.7 volts battery pack. Now let's wound the thread and see how much voltage I can get over here. Okay, positive has been connected, negative has been connected to this. Negative of the battery is here, positive here. Yeah, let's see how much it generates. You can see that I easily generated around 10.2 volts. Let's go a little harder on it and see how much more I can generate. Okay. Yeah, so it was same somewhere around 9 to 10 volts. Now comes the current generation. So for current testing, this red terminal will go over here and the pointer will come to 10 ampere current measurement mode. Let's see hand rotation current. You see hand generation is 1.2 amps, 1.3. Yeah, it's slipping a little bit because it is oily. So let's do the rope rotation for better current measurement. Okay guys, keep watching the display screen of the multimeter. Whoa, was it 9 amperes? Yeah, let me recheck the video. So guys, as you saw that the excitation voltage was just 3.7 volts, and with that rotor excitation the current was around 9 amperes, a little more than 9 amperes. That's too high. You can see that it can measure only up to 10 amperes, after which the fuse will break. So that was pretty close. Now I'm going to give one more try, second try. Okay, so guys, keep watching the display screen. 8.13 amps. So guys, that was actually 9.19 in the first, and in the second it was 8.13. So it is easily generating really high current. which is pretty good for charging car batteries or any other type of battery. Testing was really nice. So guys, in my previous videos you might have seen my electric exercise bicycle. So I have connected this DC motor, PMDC motor, 24 volts and 20 amperes. But the thing is that the current is not much, and there is a lot of cogging when I connect a load to it, so I need even higher current. Now although it is working pretty good right now, but I'm considering to replace this motor with the alternator that I just tested, because its current capability is much higher than this one. You can see here I've connected this 65 watts car headlamp bulb. I will glow and test it for you. So now I'm going to run the bicycle. Hi guys, welcome back to my channel, and in this video I'm going to use a 500 farads 2.7 volts super capacitor to excite the field winding of a car alternator for running it as a DC motor, high RPM and high torque. Now this is a digital meter for measuring the voltage and the current consumed by the controller that is going to run the alternator as a BLDC motor. Now I got this from a Banggood, and a link to buy this product will also be provided in the description. So guys, this video is sponsored by LCSC, which is a Chinese company. LCSC has grown into one of the largest electronics component distributor in China with over 900,000 customers, and they have a product range of 200,000 from semiconductors to resistors, capacitors, inductors, transistors, sensors, etc. In total, they have around 3,000 daily orders, so don't forget to check them out. Link is in the description. Guys, this multimeter can measure voltage up to 100 volts and current up to 10 amperes. Guys, it also requires an external power supply to operate with a voltage range of 4 volts to 30 volts. So guys, this is a 2.7 volts 500 farad green cap supercapacitor that I've already used in my previous video. Also guys, link to buy this product has been provided in the description, and this one you might have seen in many of my videos in which I converted a car alternator into a DC motor, and this is the alternator that I will be using to run with the supercapacitor by exciting its field, although main power will be given by the battery. And at the same time I'm also going to connect this multimeter to measure the current consumed by the alternator at no load, and also the losses of the controller and the meter itself. So guys, as you can see, the thin yellow wire from the meter will be connected to the positive of the load. The thick red wire from the meter will be connected to the negative of the load, and again the thin red wire from the meter will be connected to the positive of the load. Also guys, this type of connection of the multimeter to the load is applicable only when you are powering up the multimeter with the same load with which your load is being operated. Like I'm going to operate the controller with this UPS battery, and with the same battery I'm also going to operate this multimeter. So in that case this type of connection is applied. Otherwise, if you want to power up this multimeter not with the same power source, then you will have to connect the thin black wire that has been left out and the red wire, the thin red wire, to an external power supply ranging from 4 volts to 30 volts. Now guys, you might see that the display is fluctuating. That is because the display is switching at a very high speed, and I have recorded this video in 1080p 60 fps, and that high speed switching of the display screen of this multimeter can be seen at 60 frames per second, but it shows constant display when seen with the naked eye. So guys, here as you can see I'm connecting the BLDC controller no hall sensor type to the alternator, which you have already seen me connect in a few of my previous videos. So it's time to power up the alternator. So guys, as you can see that the armature of the alternator has been connected to the controller, and the meter is measuring the power being consumed at no load. So it is around 13 volts and 0.02 amps. Okay, so it has very less power for activating the controller, and the power being consumed by the meter itself. Now guys, note that I have not connected any external power source to the field winding of the alternator. So first I'm going to test this situation. Let's try and turn the knob of the controller. You can see that the alternator rotor is shaking, and the controller and the multimeter is indicating that it is drawing huge amount of current, and the alternator is not starting up. You can see the current is as high as 8 amperes. Okay, now what I'm going to do is connect a 3.7 volts lithium ion battery to the field and then try it. So the alternator has started running at a high speed, and the meter is indicating 12.1 volts at 2.6 amperes, and as I rotate the knob, the parameters change on the meter. Now to indicate better rotation, I have connected a clip. As it can be seen, the alternator has started running and it is drawing around 3 amperes or 4 amperes at 12 volts from the UPS battery. The speed is very high, yeah, and the operation is smooth as before. Now what I'm going to do is I'm going to use this circuit to charge the supercapacitor. So guys, I would say that exceptionally high speed is seen when the field winding of the alternator is excited with the help of a supercapacitor, and that is because voltage of a supercapacitor is very low and the current is very high. So for that reason, I think the speed is very high. Hi guys, today in this video I'm going to show you how to run a 12 volts car alternator with the help of this 48 to 64 volts BLDC motor controller. Now I opened this because I wanted to show you that I modified this alternator for making it a permanent magnet generator. You'll find its link in the description. Okay, so guys, here as you can see that this alternator has been connected to this 48 volts battery pack with the help of this controller 48 to 64 volts, and I've also connected the throttle. Okay, it's already turned on. Let's start the motor and see if it can run. Whoa, the motor broke. The RPM was too high for it to handle this kind of load. Now it's jammed, it's not going to run. The magnets that I placed inside came out, I guess. So yeah, that was something new. So anyways, you saw a 12 volts modified alternator run with the help of a 48 volts battery pack. Now let's get on with the real actual alternator. So guys, this is a DC to DC boost converter that I'm going to use to boost the volts of these three batteries. So guys, at present the circuit is not on because I have removed the clip between these two. So the circuit is open. Let's measure the output volts from this circuit pointing towards 200 volts DC mode. Output volts 60 DC. Capacitor is still charged, beware. Connecting controller to the circuit. Negative to negative. These two are positive from the controller. Positive to this positive. So guys, once again starting from this battery pack, this is a 36 volts, 12, 12, 12, 36. Positive and negative connected accordingly to this circuit. Although the connection is broken at present, output is 60 volts as tested and connected to this controller. Now the controller has been connected to this throttle, okay, and this alternator is a modified one. Again, I converted this 12 volts alternator into a 36 volts AC single phase generator. So guys, for this project I had to remodify it to the 3-phase. You see, this is the star connected tapping point for all the windings, and the remaining wires are for the 3 phases. Okay, and here at the back of it you can see that the two terminals, the brush terminals feeding the router, have not been connected, and for that I'm going to use this small 3.7 volts lithium ion battery. White is negative, okay, neodymium magnet. For holding the terminal and the battery and this wire in one place, positive. Positive has also been connected. The rotor is magnetized. Now comes the battery connection. One terminal here and the other one here. Sparking should be there. You see, indicating established connection. Let's recheck the circuit again just for caution. Yeah, it's correct. Okay, so let's try and start this motor and hope it works. Yeah, the torque is very high. Motor has started. Wow, very high speed, pretty good. Oh, it is running really nice, guys. Now guys, here I'm going to give you a closer view. Okay, once again, let's start it. Yeah, it started. Let's go a little high. Good speed. Yeah, and torque is also very good. Higher. Oh, pretty good speed. Unstoppable torque. It's running very fast. More. Oh, it is running so good, guys. More. Ha 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 ha. Very nice. Cool, right? More. Wow. Unstoppable. RPM is very high, guys. I will do one thing. Full speed. Full speed.